Hi guys! Welcome back to my channel, Algebra 1 Tutorials with Alina. If you like my videos, please like and subscribe. Today we are learning about arithmetic sequences. An arithmetic sequence is a sequence in which you add or subtract the same number each time to get the next term. In an arithmetic sequences, you also have what is called an initial value, which is the starting value of the sequence. After the initial value, we also have what is called the common difference, which is the amount you are adding or subtracting each time. So I'm going to write down an example right over here, and I'm going to write down an example of an arithmetic sequence. So let's say this is our arithmetic sequence, and you can see here that there is a sequence of numbers, and the ellipses over here signals that the sequence keeps on going. So first we're going to try to find the initial value, and we said that was the starting value of the sequence, or it can be the first value that starts off the sequence. And so the first value over here is the 7, and so the 7 is our initial value. Initial value. Next, we need to find the common difference, which is the amount you are adding or subtracting each time in the sequence. And so basically we want to find how much we need to add to 7 to get to 29. And so 29 minus 7 is 22. So that means we're adding 22 to get from 7 to 29. And so if we just want to check, again, we're going to see how much it takes to get from 29 to 51, and the answer should be adding 22. So let's just check. So 51 minus 29 is actually 22, so plus 22. So each time you can see we are adding 22. So that means 22 would be our common difference, or to shorten common difference, we would write just D as the variable. Let's move on to the next one. Over here we have the explicit formula, which is the function rule that is used to find greater term numbers. So if I had an arithmetic sequence and I wanted to find, let's say, like the 22nd term, I would use the explicit formula. And so the explicit formula is written something like this. So the function reads f of n is equal to f of 1 plus d times n minus 1. And so as you can see, there are lots of different variables in this equation. And so I'm going to write out an arithmetic sequence over here, like let's say 13, 25, 37, and 49. And it's going to keep on going, right? And so I'm going to explain the variables inside of this equation, and I'm going to show you what it looks like on the arithmetic sequence. So our first variable is n, which is the step number. If I looked at 13, that's the first value in the sequence, and so this would be step number 1. 25 would be step number 2. 37 would be step number 3. 49 would be step number 4, and so on. The next variable that we have is n minus 1. And n minus 1 is the previous step number. Our next one is f of 1. And f of 1 is the initial value. And we had said that the initial value was the starting value of the sequence. So f of 1 in this case would be 13 right here. Let me circle that. F of 1 would be 13. Initial value. And so we said that initial value was the starting value of the sequence. And so we can see that 13 is the starting value of this sequence, so that is our initial value. Our last variable is d, and we talked about that up here. And we said that d is the common difference. And so the common difference is basically what you're adding each time to the sequence. And so let's see what we're adding. Over here, 25 minus 13 is equal to 12. And let's just check it one more time. 37 minus 25 is also plus 12. And so we're adding 12 each time, and so our common difference is 12. Next, let's figure out how we're going to write our explicit formula and how to use it. So let's say that we want to find a specific term in here. Let's say we want to find the 17th term. Find the 17th term, right? And so what we're going to do is we're going to fashion this explicit formula in a way where we can find the 17th term. And so let's write out all of our variables and what they're equal to. So n is the step number that we're trying to find, and so we're trying to find 17th term, which is the 17th step number. N would be equal to 17. The previous step number, n minus 1, is going to be 16. And then the initial value we said was the starting value, and we said it was 13. So our initial value is going to be 13. And the common difference, we found it, and we said that our common difference is 12. And so now that we have all of these variables, we can fashion our equation. And so this explicit formula is going to be for the entire sequence itself, not just to find the 17th term. We're going to solve for that a little bit later. So let's write the explicit formula. So it's going to be f of n is equal to, and then we said f of 1. And so f of 1 is the initial value, which is 13. So f of n is equal to 13 plus, and then the next one is d times n minus 1. And so we said that d is our common difference, which is 12. And then that's going to be times n minus 1. So this is our explicit formula for this sequence. And so when we want to plug in or find a specific term number, and in this case we want to find the 17th, then we will plug in n and n minus 1. And so our 17th term, it's going to be f of, and then n is 17. So f of 17, I forgot the parentheses here, f of 17 is equal to 13 plus 12 times, and then n minus 1 is 16. So 16, and that is going to be our equation to find the 17th term. And so now what we're going to have to do is we have to solve for this to find the 17th term. What we're going to do first is 12 times 16, so f of 17 is equal to 13 plus, and 12 times 16 is 192, so that's 192. And so f of 17 is equal to 13 plus 192, which is equal to 205. And so f of 17 is 205, and remember f of n is the step number, and so our 17th term is going to be 205 right here. 205. And that is the 17th term. This is how you use the explicit formula. You first write out the explicit formula, and the explicit formula was this right here. And then you plug in the number that you want to find, the term number you want to find, which in this case was 17, and you plug in the previous step number over here, and you solve, and that's how you got 205 over here. Let's move on to the next one. Over here we have the recursive formula, and the recursive formula is the function rule that is used to find the next term. So the recursive formula that's really just what it's useful for. So if you know what term you have, or the value of the term, and you want to find the next term, then you would use this recursive formula. What we do, you don't really solve for other term numbers, like if you want to find a greater term number, you would use the explicit formula. But if you have the recursive formula, what we're going to do is we're going to learn how to take the recursive formula that we have and turn it into an explicit formula. And so the recursive formula looks like this. And so you can see that the recursive formula comes in two parts. The first part is f of 1 is equal to the initial value, and you'd actually write out the initial value. And then the second part is f of n is equal to f of n minus 1 plus d. And so what we're doing here is that there's one part that we don't really know what the variable looks like, and that is f of n minus 1. This is different from just the n minus 1. F of n minus 1 is the value of the previous step. So let's say we had an arithmetic sequence over here, and it's going to be like the same one that we had up there. So it's going to be 13, 25, 37, and 49. Right? And then it keeps going. And so let's say we had, let's say n in this case was equal to 3, right? And that would be this one right here. And so f of n minus 1 would be the previous step, so that would be step 2. And so in the explicit formula for n minus 1, we would just plug in 2. But when it is f of n minus 1, you replace the entire thing with the value of the second step number. So the value of the second step number is 25. And so let's move on and write this in recursive formula. Our first part that we have to do is we have to find the initial value. And so f of 1 is equal to the initial value, and we said up there that the initial value was 13. And so we're going to write 13 right here. F of 1 is 13. Then you go and we're going to write the second part of the equation, which is f of n is equal to f of n minus 1 plus d. And we said that up there that d was plus 12. We're adding 12 each time. And so plus 12. And so this whole thing right here is the recursive formula. And so what we're going to want to do over here is we're going to take this thing and we are going to convert it into the explicit formula. And so it's going to be easier for us to solve for a specific number, step number. And so to convert this into explicit formula, you need the 4 basic things, which is n, the step number, n minus 1, the previous step number, f of 1, which is the initial value, and d, which is the common difference. We already have the initial value and we already have the common difference, which is really all we need to write the basic explicit formula. And so we're going to write it out over here. F of n is equal to, and remember next is the initial value, and we know the initial value, and it's 13. 13 plus, and the next one is going to be the common difference. The common difference we said was 12. So f of n is equal to 13 plus 12 times n minus 1 times n minus 1. And so that is going to be our explicit formula. And let's see, last time we solved for the 17th term, and so let's solve for the 17th term again, just to make sure that we're doing this right. So if we solve with the explicit formula, or if we have the recursive formula and we convert it to an explicit formula, if we have the same arithmetic sequence and the same step number, we should get the same answer. And so let's solve for the 17th step. And so it's going to look like f of n, and n in this case is going to be 17, is equal to 13 plus 12 is equal to 13 plus 12 times n minus 1, which is going to be 16. And then we're going to solve for this. F of 17 is equal to 13 plus 12 times 16, which is 192. 192. And so f of 17 is equal to 13 plus 192, which is 205. And that is the same answer we got up here. And so f of 17 is 205. So this concludes our arithmetic sequences notes portion. I'm going to do the practice problems for this topic in my next video. I hope you guys understood everything that I explained in the notes. Please make sure that if you have any other questions, you can comment them down below or comment any other Algebra 1 topics you would like me to cover. Like and subscribe. Thanks for watching. Bye!